Oh, hello, hello. Welcome back, everyone. I didn't stream for quite a few days because streaming was getting a bit hectic. I was trying to find a rhythm, as I said, and also I didn't have my, monitor back then. I have my monitor now, so today it will be easier. I can see the chat also, so if anyone is there, I can clear that out. And I can see the screens also, so hopefully OBS doesn't glitch. And if it glitches, I can catch it immediately, so you don't have to, look at a blank screen or stare. So that's good. Monitor is here. So today I didn't, because it's been a bit of a gap. I just wanted to, do some recap, do a bits of small kind of, projects, and then do some recap. So we read about intro, we read about control flow, if while loops, if else loops, for loop, about those things, right? Also, we read about data types, what kind of data are there. There are numbers, there are strings, booleans, and then there are collections like list, tuple, set, dictionary. Then we learned how to design a function, why a function, what is an argument, what is a function parameter, what is a keyword argument, how to call a function, when to call a function. So how to, do basic recursion, how to combine position and keyword functions. So we learned all that, right? And then we learned also operators, what are arithmetic operators, what are logical operators, what are comparison operators, what are identity operators, membership operators, and bitwise operators. And most important thing of all, we have learned OOPS, right? We'll go into OOPS in much more detail. Like everything we do from now on will center somewhere around OOPS, right? So OOPS is one of the major, if you are ever getting into any kind of programming language, which is the object-oriented programming language, which are the trends nowadays. You take Java, you take Python, you take C, you take C Sharp, you take C++. Everything is an object-oriented programming language. So OOPS will be same in all the cases. The backbone of OOPS, the syntax of OOPS, of designing those object-oriented programs will be different, but the backbone will be same in all cases. So once we have learned OOPS, we have learned covered a very big chunk. So we have taken a very big leap. We are no longer beginners. We now start to understand code. We now start to realize what is happening. We can now relate to what is happening in the real world. So there's that. Let me just share the link. So, everybody starts joining a bit of. I would like if people join. Let me open the chat also. Yeah, we have the chat. Chat is here. Let me share the link to a few places. So I will just start, and today we'll do 3 or 4 projects, minor projects, like from very beginning basic projects to a bit advanced project. One I have already designed. If you can see here, I have OOPS project ready. So this is already designed, but this is probably we'll do today or tomorrow. Mm, so Okay. Cool. So what I was planning today and what not I was planning, I am actually going to do is start with a project which is a very easy project and which will refresh some of our memories. Is something this. So we'll start with this thing. Let me just take a. We'll design a simple calculator. It's a simple calculator. Now, while designing any project, you should first keep in mind what the end product is, why the end product is, and how we will reach to the end product from the raw material. So, what is the end product? End product is a calculator. What does a calculator do? It performs basic, for a simple calculator, it performs basic arithmetic operations. What operations? Addition, subtraction, multiplication, and division. Right? These four. How does it perform? It takes in two numbers. Let us say x1, x2. So these are the operators. X1 and x2 is acted upon by operator and we get an output. See, so here what all concepts will be clearing? The concept of user input and output, system output. So this will be clearing the concept of operators, arithmetic operators. And here what is happening? So since there are many operators, there's a particular flow that should be following, right? The input comes, this whole flow, and which operator to select, the conditional flow. So we'll also cover flow, basically control flow part, right? So in this very first project, we are already covering three major portions that we have already learned. So let's get into coding and not waste much time on designing, since it's a very basic project. So I'll just shift my screen. So new file I'll name simple calc. Okay, I'll just write in the full thing. Simple calculator. So how does a simple calculator work? So we need two numbers, right? So let's define x1. So already you can see that the IntelliSense is picking up. So I'll not type much. I'll just hit tab. So what it's doing is it's taking an input which is saying it will prompt the user to give a input and then it will convert it into float because the input that comes is a string and we cannot perform arithmetic operations on a string. So if you want to perform arithmetic operations, you have to turn it into either an integer or a float. Why a float we are preferring? Because integers are sometimes not perfectly divisible, or integers are when you divide two integers, you might get an integer and you might not get the exact rounded off result. So that's why we're preferring a float. Oh, it is looking now. Yep, it was. Okay, so this is our x1. Similarly, we'll get a x2. So this is our x2. Now, also we in this project we'll get to refresh our. I think the network dropped. Yeah. So also in this project we'll get to refresh our ideas about the data types. So what we'll do, we'll just first do a basic sum. A basic sum. How will we do the basic sum? We'll just print. x1 plus x2, right? Similarly, we can do a basic difference. So how will we do the difference? We'll print x1 minus x2. Okay, because generally in a calculator, we enter a minus b, not a and b, and then b minus a will do. That also happens in scientific calculator we do, but in a simple calculator we enter two numbers in sequence, and we want the difference of the first and the second number, right? What else we want? We want a product. We want product. So let me write it properly. Difference, and then we want a product, and then we want a quotient, right? So this will give us a quotient. Now let's just print. Let's just run it like this. Why is my screen not visible? For the OBS glitches, I swear to God. So basically, what I was saying is, we want a sum, we want a difference, we want a product, and we want a quotient. When we enter two numbers x1 and x2. Okay. So we'll prettify this later. Let's just run it once. Okay. So let me say I have first number is 10 and second number is 2. So the sorry, I put in 22. Let's just run it again. 10 and 2. Why is 2 getting pressed twice? Some issue with the keyboard. First number is 10, next number is 2. See, 10 plus 2 we get 12, 10 minus 2 we get 8, 10 into 2 we get 20, and 10 by 2 we get 5. What if we don't have perfectly divisible numbers or perfectly proper subtraction results? So suppose the first number is 2 and the second number is suppose 5. See, 0.4, we get a minus 3. But then in a calculator, when you enter two numbers, we have to press the operator that yes, I want to do this operation. Then only it gives us the particular operation, right? So, so that's what we're going to do. So first we need the all the operators listed out. So what are all the operators listed out? Operations is, or we don't maybe we don't need the operators listed out, right? We can always mention it in the for loop, but we want the user to give an operation, right? What kind of operation you want? You want a enter operation. Here we will list out what operations are available: plus, minus, multiply, and divide, right? These are all the operators available for now. Now, how will we display the particular result depending on the user's input? That's where if else comes in. So we say this part will just keep it like this. But for sum, how is sum displayed? When if operation equal to sum. So indentation, guys, indentation. So we print this. We print f sum of, or we can just say uh, x1 operator operation x2 equals x1. What's okay? This one x2, and we need to close the string, right? So let's just run it once. We enter the first number is 2, We enter second number is 3. For now, we only have plus defined. So we just give plus. See, 2 plus 3 equal to 5. Similarly, we'll just do for every one of those, we'll just write that. So we say after if we get elif operation is minus, print the same thing that x1 minus x2 is x1 minus x2. Similarly, we go elif operation is multiply, we print the same thing. Then we go elif, the operation is divide, we do the same thing. Now, what if the user input something weird, like user thinks that, oh, let me get the power, let me get the exponent, and he enters double star, which is basically operator. But in our program, we don't have the support for double star, so we need to give the user a error that yeah, you have whatever you've entered, that's an error, and you need to rerun it or re-enter the values. So we have the else statement, else print invalid operation, right? It works. Let's run it once and just check it. Enter first number, anything, say 20. Enter second number, say 3. Enter operation. So we know that plus minus will work. So let's just go with plus 20 plus 3, 23. Beautiful. Enter first number, we get 40. We get 7. We go with divide. See, 40 by 7 is something like this. This kind of value. What if we enter something which is not in the operation list? Enter first number, or what if we enter something, you know, okay, let me just do this first. 20, and then we go 2, and then we go enter operation is exponential. It's invalid operation, right? What happens if we do this? P. See, we get an error. But this we cannot show to the user, right? That oh, traceback. The user doesn't know what a traceback is or what anything is. So we have to package it and explain to the user that whatever you've entered is wrong. So we can use two ifs here. If not, or better, we use a try catch. So we put the whole of this in a function. We name it main. Uh, we used to design functions like this. That main. And this is what is called basic error handling. We'll look at it tomorrow. So what we can do is we can do it try catch. So for now, let's leave it. When we'll do tomorrow, I'll just explain it then. So this will be an upgrade to our calculator. So here we just keep it written, add error handling for end user, right? So this will do when we learn about error handling. Okay, so we'll do one more basic project. Mm, let's see. Let's think about one basic project. Um, Let me see what I have planned. The basic projects. Let's build a game. Okay, let's build a rock paper scissors game. So we'll name it rock paper scissors. We'll just design one game. So what happens in a rock paper scissors game? The user enters the input. Um, okay. So something we have to know for the rock paper scissors game, there is generally two users, right? So, but if I'm entering the input, I'm playing against the computer. I'm not entering two inputs and going like, oh, I do one. So I have to go against the computer. So computer has to make a choice from a set of commands. Like It either has to choose a rock or a paper or a scissor. That's what the computer has to choose. And then we need to compare it with the user's operation. And then we need to say that, yeah, you have won or you have lost. So whatever you have. Sorry about that. My screens are, doing a bit of. Yeah. So let me just switch to the screen and let me just explain what I was going through. So rock, paper, scissors, right? Rock, paper, scissors. So what happens? We have two players. Two players. One is our computer. One is our user. Right. So since we're just keeping it basic, since we're just keeping it basic, we give the computer whatever. We give the computer a set choice of commands that you can either pick rock, as paper, or a scissor, and the user will type in their command like rock or a paper or a scissor. So if user gives in rock and computer chooses a rock, it's a draw. If user gives in a rock and computer chooses a paper, computer user loses. If user gives in a rock and computer gives a stone, user wins. Right? So this is how it's going to go. Now, how does the computer choose one? We cannot hard code that, yeah, first three times you choose. It's not good to hard code, right? So we have something called a library, which is random. So what random does is random has this function, random.choice, where you pass in a list of things and it randomly chooses anyone. Right, random.choice, you pass in a list of things and it randomly chooses any one of them. So we'll look at that. Okay, let's go to our code. Beautiful. So rock, paper, scissors. First, we have to take a user input. User input equals to input, enter rock, paper, or scissor. Right? This is our user input. Now we take the random library, input random. Okay, and we have, okay, my battery is low, so let me just switch. Yes, This is also working. Okay, this is the user input. Now we have a computer input. So what will it be? Random dot choice, random dot choice out of rock, paper, or scissor. So it has to choose any of those. Now we write a if else statement. So if first case user input and computer input both are same, then we say draw. Right? In both three cases, if they are same, then we say draw. Elif user input is a rock and computer input is a scissor, we print that user wins. User wins. Else, what is the else condition? User input is a rock and computer input is a paper. So computer wins. Similarly, we'll write this for the other cases. If user input is a scissor, then what's the user win condition? Obviously, you all have played rock, paper, scissors, right? If computer chooses a paper, else computer wins. Else, if you else, what else user has not taken paper? If computer input is a rock, user will win. If else, computer will win. Right? Now, what if the user says that yeah, rock paper scissors, I'll play rock paper scissors lizard Spock, but our game does not support lizard Spock. It's I'm not Sheldon. We're not mentally disabled. I'm sorry. We are not mentally too. Thanks Akash for the support. We are not mentally too fast to play the rock paper scissors lizard Spock. Some of you might be. I'm not. So what happens when we put in else? What print invalid input? Choose from rock, paper, or scissor. So okay, rock, paper, or scissor. Okay, let's run. Let's say I have taken rock. See, it says invalid input. Choose from rock, paper, scissor. Do you know why? Because Python is a case sensitive language. So this lowercase rock will not work. Now what we can do is we have learned string methods. So whenever the input comes in, it comes in as a string. We can just convert it into a lower. So here we can say rock. Here we can say scissor because it's already in lower, right? And here we can say paper. So we'll just do this. We say rock. Mhm. Oh, never mind. I put a space there. So we say rock. User wins. But now the user doesn't know that user knows he wins, but it will be better to show what the user picked and what the computer picked. So we can just print a string user picked, user picked, user input. Now user input dot upper. Why dot upper? Because it looks better. And computer picked computer input dot upper. This is one line, right? This one line has to be there in like four or five places. We'll just copy it and we'll just paste it. We'll copy and then we'll paste. We'll copy and then we'll paste. We'll copy and then we'll paste. We'll run it. Let's just say I type rock. User picked rock and computer picked rock. Computer wins. Now, why does computer win? This should not be. Okay, you see what has happened here? Let's just debug it. There's very nice thing called a debugger. Uh, Now it will not work obviously because the computer might have another random choice. But what happened was actually, let me just describe it to you. We said rock, it went as an input, it got transformed into lower, and our input effectively became rock. What the computer picked was rock. Now, these two are not same, not same. And then it goes to if user picks rock, the win condition doesn't match, and else condition is everything, right? The else condition is everything. So it says that, yeah, computer wins. But it's not correct. So what we have to do, we have to also change the computer once to maybe, to match the user input. So how we do here, if user input, what if we just change it into title? You know, we also had title or capitalize, right? So we'll just change it to rock. We'll just change it to scissor, and we'll just change it to paper. Now it will work perfectly. Let's say paper. User pick paper and computer pick scissor. Computer wins. So now every time it runs, it just ends. You pick one, you end. For when you're playing rock paper scissors, you don't want to have it at one point. At least we play 3 points, or at least we play 5 points, right? So how can we do that? We can just use a while loop. Okay. So we take a user input and we take a while loop. So we say while true, right? So we just say while true this, or while true. Should we use while true? Press Q to quit. We give the user an option to quit, right? While user input not equal to Q. So as long as the user is not pressing a Q, will not quit. As soon as user presses Q, we print out. So it exits the loop. We print out. Thank you for playing. Let's print it. Press Q to quit. I say paper. Wait. Something has happened. Okay. Hmm. Let's see if anyone can spot it. Well, basically, what is happening, we are setting the user input before. So once we set the user input, this loop goes on infinitely, right? So we have to head the user input inside. We just define it as a blank string so that it's initialized, and then we do this, right? So let's just run it and hope it works. Okay, we enter paper. It's a draw. Okay, in the draw line, we have not pasted this, so we'll just paste it. We'll just rerun it, right? Stop and rerun. We say paper. User pick paper, computer pick scissor, computer wins. Enter rock, paper, scissor, press Q to quit. We'll say maybe one more round we'll play. We'll play rock. User win. So it's 1-1. So for the third, it's like winner takes it all. So we'll just take scissor, computer pick scissor. It's a draw. So nobody won. Nobody won, right? Now I don't want to play anymore. I just want to quit. Uh-huh. So what happens is when you pick Q, the loop all at least runs once more, right? So we can just say if user input is Q, then break out of the loop. That works. And then the all else will happen, and this will just say while true. So it will occur every time it will occur. This we need not initialize, and now it should work. Let's see if it works. Let's say paper doc tree. See, I've given the wrong input, so it's giving let's say doc and let's say tree. It should give an invalid, and let's press Q. So when we press Q, it breaks out of the loop. We learned about break and continue, right? And it gives us thank you for playing. Now, what if we wanted to have points, right? So let's have a points. Initially, points will be zero, right? So when will points increase? If it's a draw, there will be no, issue of points. If it's a user wins, we will say points plus one. Now we'll just points is plus one. User wins. You now have you now have points. Some points, right? So copy this part, not the whole thing. This part we paste it everywhere. Just paste it everywhere. And now we just make everything f string. This, and this will be made an f string. And now the points will be updated. So when we lose, we can also just write points plus equal to one, right? We have learned this. We can just say it like this. So we can, if we lose, we'll say points minus equal to one because 1 point will be deducted. We have lost. So point plus equal to one. Here also point plus equal to one. Here is point minus equal to one because we are losing. And here is again point minus equal to one because we are losing. Right? This works. Okay. Let's just run it once more. Rock. Use a pick rock, computer pick rock, draw. Okay. In draw also, we'll just show that how many points you have. Right? Draw. You now have points. It's better to show the points. User pick rock, computer picks scissor, user wins. You have 1 point. User picks quarter. Invalid input. User picks tree. Invalid input. User picks scissor. Correct input. Draw, but now you have only 1 point. So thank you for playing, we can also display the points here. So we'll just say you now have some points. And we'll keep it like this, like the dot format, because F strings we have already learned. F strings is the best thing, but since we have already learned dot format, we'll just use it somewhere, just for the sake of it. You now have 1 point. Let's say paper. It's really getting boring to play. Use a pick paper and computer pick scissor. Computer wins. You now have 0 points, and I just want to quit. Thank you for playing because I've written this after I've run the file, so it has not yet updated. Later it will update. Like if you want to see rock paper. And now I have 1 point. I just quit. Thank you for playing. Now you have 1 point. So this is the basic rock paper scissors. So we'll just take a 5 minute break. I'll be right back, and we'll do one more project today. A better one than this. We'll do one more project, and then we'll wrap it up for today. All right, guys, welcome back. Let's just do this. Now we'll do something a bit more complex, but a very interesting. So what we'll do is we'll design a to-do list. So when we have a to-do list, what is our basic function? We open the to-do list. We have a menu. We can do multiple things. What we can do, we can view all our tasks. We can add all our tasks. We can mark done for one or more tasks. Then we can delete a task, right? One or more, one or more, add also. And then we can quit the application. So these are the basic things we can do. So each of this is a particular function. So now we'll be using functions. Remember we defined functions. So now we'll be using functions. So this menu has to show. So for that we'll use a show menu function. What will show menu do? Show menu will generate a list, and according to the list you can select the options. So once the menu is shown, it will generate a menu, and then we'll go into control flow. How? Suppose we get one is view task, two is add task, three is mark task, and four is delete task, and five is quit. So if user input is one, we call the view task function. If it's two, we call the add task function. If it's three, we call the mark task function. Right? That's how it works. Let's code it out so that we can better understand it. Let me just uh, okay. So let's just define all the functions. So we have a function called show menu, and we'll just pass. For now, we'll just define the functions, right? Then we'll decide what to do in this. Define add task, add item or add task item or add item, and we'll do pass. Define remove item. This is also pass. Define mark item, mark item. This is also pass. Define show all items. This is also pass. For now, we'll just do a pass. Like we'll not add the functions. We'll first go into the user part. What the user will do. We just say that user input equal to input. We just keep it inside a main function, right? So we say def name. So how will the user input if he doesn't get the menu? So first we have to call the show menu. So let's write the show menu. What will the show menu do? It will print welcome to welcome to-do list, right? And then it will, let's just keep it like this. Welcome to to-do list, enter. We'll just print multiple things. One, view task, view tasks, task, two, add task, three, mark task as done, mark is done, four is remove task, five is quit, right? We'll just comment it this part out for a second and we'll just see if show menu works. So one thing we will have to do, we'll just explain it later. This is called a main. This is called a directive. So basically, what happens when you enter a function, the first entry point of that function by default is this thing, main. So the name has to be set to main. So when we say if name equal to main, it means you're entering that function. And when you enter that function, the first thing you want to do is run the main function, which is this one. Let's just run it. Are we running rock paper scissors? Oh, no. It's Python doing Python things. So we get welcome to to-do list. One is view task. Two is let me just put this also in enter. Take to do list. And then we'll just have this and then we'll just do something like this. Right. Okay. But works for now, right? So this is our menu. Now after the menu, we should have a user input, enter and input. Right. So when user inputs one, if user input is one, we view the task. So show all items. Show all items. What the what the hell? What the hell? We see show all items. Right. So now we have to go there. What? How are the items stored? So items have their particular. So now we are going into data structures. Item has a particular name or a particular, title that wash clothes or do code, and then they have a status. So they are a key value pair. How is it best to store the items? It is best to store the items as a dictionary, right? So we'll say items initially is an empty dictionary. What is in show all items? So basically in show all items, what will you do? We'll just go there and we'll just say that yeah, there are no items for now. So you cannot add anything. So not here. We'll just make it here. Items refer to tasks, right? Items refer to tasks. Items refer to tasks. Now show all items. If we push pull in items. So what if there are no items? So if not items, print no items. No items are there. No items. No tasks are there. Since it's a to-do list, let's say no items present. Else, for item in items, we print item dot key and then the value that if it's done or not. And we do it via a string. So like this, and this is inside contact parent. This part is inside contact parent, and we'll say that if it's done or not, right? So we have to pass the items. For now, let's see how it works. So enter, user says enter input. I say view task, no items present, right? Now the menu is not shown to me. It exits automatically. So what we should do? We should use while true. We should use while true here, similar to the first project that we made, the calculator. And until the user presses Q, we'll just prompt him that yeah, just keep on doing whatever you want to do. Let's do it again. Enter an input one. What will happen? There is no item present. Same issue we've done. We've taken user input here. It should be taken here, right? Let's just write the elif case for user input 2 now. So what is that 2? Add task. So add item and then we use user item, right? So we get user item here. So what happens if user item is a valid string? If so, user item is already a string, right? So not user item, user input. So we set user item is equal to user input. See keyword argument, guys. We can also pass it as positional argument. So if not user item, suppose user item is blank, the customer has not entered anything. We'll just print invalid input. Else, what happens? So here we also pass in the items dictionary, right? The items dictionary. Else, items. Now the user item. Since since I've just entered it, since it's my to do, so obviously its status will be not done, right? So I'll just mark it not done, right? So let's just try it. Let's just try working it out. Say enter an input. I have input at 1. No items are present. I have entered 2. Enter an input or enter an item. We should really. Oh, okay. So if user input is 2, we have to give another user item is enter item to add, and here we'll go user item. So now 1 will give. Oh, yes. So in show all item, when we're taking the item, we are already taking the key value field. So what we do is we print the item and we print the value of the item is printed like this. So we'll just rerun it, stop and rerun, enter input, enter suppose 2, enter an item to add, go to sleep or sleep, right? So now I need to check what all my tasks are. Go to sleep early, not done. Right? So basic structure, backbone is now starting to form up. What next? We next get elif user input is 3. So what is that 3? We mark as done. So we go, you know what we can do? Instead of using the user item here and passing it as an argument, we can just, if this is like this, we can just go here and paste it. We can just pass in the items dictionary. and we don't have to worry about it. So now when the add item is worked, then the user item is called Kutsi. It is called by itself. Similarly, so when we have to mark something as well, so we use mark item and we pass the items. So user, suppose the user has inputted 50 or mark item will take a item. Suppose the user has inputted 50 items and he does not remember what item he has to. So first we have to show him, show all items, right? So when the user sees it, user item, enter item to mark, done. So user will enter, right, this item, I will marking it, done. If user item in items, item dot user item, done. And then show the user, or else uh, we just say not a valid item, print item not found or not a valid item, right? So and then we again show the user that yeah, these are all your items. So let's just work it out. Suppose we enter into two. I say item is go to sleep early. Then I want to see what all I have, which not done. And then we have three, mark something done, enter item to mark done. See, go to sleep early is not done. So in show all items, we can also do uh, else print your uh, your current items are as follows. follows. It will be so enter item to mark done. Go to sleep early. Enter. So it is marked as done. Now the penultimate user input is elif user input is 4, remove item, and then we have to pass in the items dictionary. So we ask the user similar to the add item. We ask the user enter item to add. No, we do it like this, right? So we do it like this. We first show him all the items. We first show him all the items. Enter item to remove. For user item in item dot user item equal to uh, so we can just use pop, right? So items dot pop user item, and if it's not there, oh, items dot pop items dot pop user item. So let's just say I enter something small now, sleep. So we enter into one. The current item is sleep and it's not done. So we can take the user items and we can capitalize them. So it will look better. So now we enter input like 3. So what we have to mark done, we mark done sleep. Sleep is done. Now sleep is done for us. So not capitalize it here. Sleep is done for us. So now we enter input 4. Enter item to remove sleep. Since sleep is done, I'll just remove sleep. Right? Now no items are present. Why is no items present? Because the only item that was present, I have deleted it. And now I'll go and write elif user input as 5. Break, but print, just give a print exiting, exiting value. So what happens in this is the items part. The items part, it always is initialized as a blank dictionary and it is not saved, right? It is not saved because it's initialized inside the main. Every time you you run the main function, it's newly initialized, so it is not else print invalid input. Now, some task you have to do. If anybody is watching, you do this. I'll also upload it on the GitHub. I'll just comment it and write it. Prettify the show items. How to prettify? Add, because sometimes we enter something long, right? Like do write a piece of code. So we will not write the whole thing well every time. We'll just use their index. So add index. So it should say one. So for example, it should say one sleep, uh, two work, like this. Like this, it should say. Uh, one more task is rewrite or modify the functions to work with the specific index. For example, what functions? Basically, mark as done function and remove function. So we can just say that, yeah, the fifth one or the sixth one, I just want, and it will just do it for us, right? So this is something you can do by yourself, and we will probably tomorrow also we'll come back and we'll check on this. So this is it. This is it for today. This is a very basic to-do list. Hopefully you enjoyed the content. Hopefully you learned something. So if you learned something, definitely subscribe or like and a share would be very much appreciated. That's it for today. Do let me know what other kind of content you would like to watch, like what other doubts you have, or if any particular topic you want to know, if any particular small topic like today, as I explained, the random. Here we have the random module. So if you want to know more about modules, or if you want to know more about this, how I use this thing, so you can tell me, I'll make short videos, or if we'll talk about it in the beginning of the next stream. So that's it for today. Have a nice day.